Hello, in this video I want to tell you about solid principles. And let's start from the first principle. It is single responsibility principle. It means that a class should have only one job to do. It should focus on doing one specific thing. The order class in this example has two responsibilities. First is creating an order, and the second is saving it to the database. And this violates the single responsibility principle. If a class has multiple responsibilities, it becomes harder to understand and maintain this class. We see order and two methods, create order and save order. That violates single responsibility principle. So let's rewrite this code so as to get it in conformity with the single responsibility principle. So here we can see bad example, and let's create good example. So we just need to separate responsibilities into two separate classes. Create order, first class, that would be designed for creation and saving orders. So here we see diagram of updated classes, which designed for specific responsibility. Order saver is designed for saving orders, and creation order is designed for creation orders. So we divided our previous class into two new classes. Let's move to the second principle, and this is OpenClosed Principle. It says that we should design our code in a way that allows us to add new features without changing the existing code. For example, this shape class violates the OpenClosed principle because it requires modification whenever a new shape is added. So we have class shape with private field string type. And when we receive type, we calculate area based on the type of shape. So whenever we need a new shape, for example, it would be circle, rectangle, triangle, we should update this class. And this is violation of OpenClosed principle. So this calculate area applies to all types of forms. And it is better to divide this class in a couple of classes, and we can add new features, for example, new form such as triangle, without modification of existing class. So let's create new example. It would be good example because we rewrite our previous bad code, and we will have interface shape with method calculate area, and we will have each class for separate form for circle, triangle, rectangle, and so on. So we can add new form without modification of existing code. So our class circle will implement interface shape, and also we will implement method from this interface calculate area. So each our new shape will implement this method from interface shape. So we will have such diagram where we have interface shape, classes circle and rectangle that implement this shape. So if we want to add triangle to our previous class, we need to update existing code, class shape. As you can see, we added triangle and we updated our code, and here we would calculate triangle area. If we applied OpenClosed principle, we just need to create new class, and we will not modify the existing code. So we created new class triangle and implemented method calculate area of interface shape, and this example does not violate OpenClosed principle. So we just added a new class to our existing classes in accordance with OpenClosed Principle. Next principle is, let's go, Substitution Principle, and it states that objects of a superclass should be replaceable with objects of its subclasses without affecting the correctness of the program. And Robert Martin summarizes it: types must be substitutable for their base types. By not supporting this withdrawal method, the fixed-term deposit account violates this method specification. We cannot substitute fixed-term deposit account for account, because fixed-term deposit account does not provide for withdrawal. Here we see exception, and this fixed-term deposit account throws an exception for withdrawal. It does not provide withdrawal option. So we need somehow separate this withdrawal account, fixed-term deposit account, from other accounts. And in this case, we copy our existing classes. In this example, we created new withdrawable account class that would be extended by classes that provide withdrawal. This is savings account and checking account. And this withdrawable account will not be extended by fixed-term deposit account because it does not provide for withdrawal. So this is withdrawable account would be an intermediary between accounts that provide withdrawal and account class. So our abstract class account will no longer have withdrawal method, and each account will have all methods from account class. So each class has deposit method, but only withdrawable accounts have withdraw method. But fixed term deposit account does not provide for withdrawal, and we removed such withdrawal method from fixed term deposit account. Next principle is interface segregation principle, and by separating interfaces, this principle helps in reducing dependencies and promoting flexibility in code. It means that we should design smaller and more specific interfaces. In this example, machine interface violates the interface segregation principle because it includes methods for both printing and scanning, which may not be supported by all implementing classes. So let's create a good example and separate our interface into two separate interfaces for printing, for printer interface that would provide for print function, and scanner interface that would provide for scanner function. In such case, we have two separated interfaces, and if a machine provides for scanning option, it will implement only scanner interface. And if the machine provides for two options, such as scanning and printing, it will implement both interfaces. So we can see that all-in-one printer implements printer and scanner interfaces. But printer machine implements only printer interface. So if we see class diagram, we see that previously we had one interface machine that was implemented by both classes, and in this example we have two interfaces that can be implemented separately. The dependency inversion principle states that high-level modules or classes should not depend on low-level modules or classes directly. Instead, they should depend on abstractions. In this example, the music app class directly depends on the concrete implementation of rock music player, violating the dependency inversion principle. It tightly couples the music app class with the rock music player class and limits the flexibility to switch or introduce new types of music player without modifying the music app class. So if we need to add a new player, we should update this code and create new interface music player that will have method play music. And we will have separate class for rock music player that would implement our music player interface with method play music. That is saying that we are playing classical music and rock music. And also we will have class music app that would take music player as a parameter and play music depending on a parameter we take. For example, we can take both either classic music or rock music, and our high-level class will not depend on low-level class. So our interface is not dependent on specific realization. We can take either classic music or rock music. So if we run our main method, we see that classic music is playing, and if we create new object of rock music, we can see that rock music is playing. And here we can see our diagrams of updated class high dependency. So rock music player and classic music player and player are not dependent. So thank you.